let's look at a solution for the queue time problem. So there are a class of problems in computer programming that deal with items coming out of a queue. A great example is the self-checkout line at a grocery store, where you have one line of shoppers waiting to check out at multiple registers. So we're thinking about a self-checkout line. So there are multiple stations. If you've been to a self-checkout where there are multiple stations and each person goes and checks out their own stuff. So one line of shoppers wait to check out at multiple self-checkout registers, multiple stations. So for example, or for this example, imagine that everyone can only check out one item per second. And a second is any arbitrary amount of time. We're just saying a second for the sake of argument, for having a point of reference, right? But this could be one item every n seconds, or every 10 seconds, or every minute, or something. So, and we're going to assume that everybody takes the same amount of time to check out one item, right? Okay. So write a program called queueTime that will calculate and return the time it takes for the given queue to get processed by some number of processors, stations, self-checkout stations, processors. Okay. The function has two parameters. The one called queue, which is a list of integers representing a task with its value being how long it will take to complete. So essentially, this is a list of people in the line, and each number is how many items they have in their cart. So the first person has 3 items in their cart, the second person has 7 items in their cart, the third person has 5 items in their cart, in this particular example. So this is a list of cart sizes. And then the second parameter is the number of processors, or the number of self-checkout stations that they have available to them. Will represent the number of processors to work on the queue. Okay, cool. So let's get this function head written and get all the obvious stuff out of the way. Def takes in, I'm going to call this, it says to call it queue. I'm going to call this cart sizes list, and this will be num stations. We'll call that number of stations. And then what did we want to return? We want to return the time it's going to take for for all of these stations to process all the items in this cart, right? So the time is going to be essentially equal to the station that took the longest. So what I can do is just return essentially the longest station. So well, we'll get to that in a second here. So right now I'm just going to do a list, and we'll return this list. And I'm going to change this a little bit, but just to have something in there to get us started. Okay, so we should see some empty lists. So let's step through this problem. In cases like this, it's good to just kind of step through it. You can do this pencil and paper. I'm going to do this just in my text editor because that's how I prefer to work, and it's easier to present that way. Cool. Okay, so imagine we have our list of cart sizes. So I'm just going to say cart sizes list equals 3, 5, 2, 9. And our number of processors equals 2. What do I wanted to call these num. I'm going to call it stations. Stations. Okay. So these are our self-checkout stations. So what if I had a way to represent each station individually? I need to represent the time taken for each station. So I know I have 2 stations. So let's just make a list. We'll call this stations list. Excuse me. Stations list will be a list with 2 stations in it. We'll have, we'll start them both at 0 because we're starting this problem. So at the beginning, they both have taken 0 time. Okay, so let's go through this. The first person has 3 items in their cart. They can go to either station, and we're going to make a little rule. If at any point there's a choice as to which station to go to, the person will just go to the station on the left. So they'll go to the station with they'll go to the first open station. We could think about it like that, or the first station in the list that's open. So they'll look for the station that's open, and they'll go to that one. So the first person has 3. They go to the first station that's open, and they have they add a time of 3 to that, right? Well, at the same time, since we're just starting, the person with 5 items in their cart, the next person, can come to this station. So the first 2 people go, and they go to the 2 empty stations. One takes 3 units of time to complete. The other takes 5 units of time to complete. So the first station that will be open is this 3. So 3 will be open before the 5, obviously, because 3 units of time is less than 5 units of time, so 3 will be open first. So whichever, so here's another rule. Whichever station for any given person in this list, right? Whichever station has thus far taken the lowest amount of time to complete is the station that that person goes to. So we have this person with 2 items in their cart, and they're going to go to, they're going to go to this first one. So 3 plus 2 is 5. So again, right, we have 5 and 5. The last person in line has 9 items in their cart. So these two stations finish at the same time, so they have a choice. So they'll go to the one on the left. 5 plus 9 is 14. So the time taken to complete this system is 14 because it's the largest number here. Okay, so let's think about that again. Let's just do this again and write down those rules. So the first rule is if the customer has a choice of stations, they'll go to the like if there are multiple stations that all share the same value, and that value is also the lowest value in the list, they'll go to the one on the left. Or we'll say, well, they'll go to the leftmost station. Okay. The second rule is, I need to step through it to remember the second rule. The second rule is, oh, really, it should be the other way around. We just discovered them in the opposite order. Oh, okay. I'll own it. Okay, so the second rule, sorry for the confusion. The second rule is that each customer goes to the station with the lowest number, because the number represents the amount of time thus far taken by that station. So each customer with the lowest number. Cool. So there's another sort of question here, which is how do we make a list like this? Because I can't come in here and like, well, this will work for 2 stations, but remember num stations has to represent any number of stations. So I might want 1 station or 3 stations or 2 stations. So think about that for a second. So what I can do is I can concatenate. This is a kind of concatenation. You can multiply lists by integers, which is kind of a weird one. But num stations is an integer, and I want as many stations, and I want to represent each station with a 0 initially. I want as many stations as there are, as is equal to the integer called num stations. And I want to represent each station as a 0 in this list, initially at least. So this will give me my starting state. And then remember, what I wanted to return is after this whole process is finished, I want to return the largest number in the list. So we'll return max of list. And let's give this a better name. Let's call it stations list. Oops. Oh, you know what? Actually, no, I'm just going to call it list. It's nice and simple. All right, so now let's write the main body of our logic. So let's say we know we want to go through each cart in the list of cart sizes. So I'm going to say for cart in cart sizes list. For cart in cart sizes list, we will say we want to add the value to the station with the lowest value. Excuse me. So we want to add the number of items in the cart, which is represented in the variable called cart. We want to add that number to the item in this list. Okay, I am going to change the name of this. Stations list. We want to add it to the station with the lowest value. So right now they're all set at 0. So we can just get the first one that shows up. So what I want to do is we'll say stations list substation, and I'll come back to that in a second, plus equals cart. Maybe we should call this cart size. Cart size. Okay, so what is station? So station has to be an index. So let's make a variable for this. We'll say station equals the index of the min. So we first we have to find the min of stations list. So min stations list, and then get the index. So min will return the first, well, it'll return whatever the minimum value in the list is. And we want to get the stations list dot index of whatever that minimum element is. So we get that minimum element, we get the index of that minimum element, and the index is going to return the first index that occurs in, right? So right now we have a list with Well, actually, let's do this second test here. So right now we have a list with 2 zeros in it, so it's going to return that first 0. And so min stations list is 0, since they're all 0. Index of that 0 is, not to be confusing, but 0, because it's 0 as the first element as well. And we'll set that to station. So we'll get index 0, and we'll say station list sub station, maybe I should call this station IDX, station index. And we'll get that index, which is index 0, and we'll add the cart size to that 0. Once that's all done, we should return the max stations list, and let's see what we got. So that gives us 8, and that's actually what we expect for this test. So let's run our other tests. Cool. So I expect, from my tests, I expect 15, then 8, then 10, then 22, and I get 15, 8, 10, 22. Looks good. And you could definitely optimize this and sort of, I don't know, I mean, you could cinch this down and kind of maybe clean it up. You could write this as a comprehension if you wanted. But yeah. Cool. Hope that helped.